Good evening, and welcome to Hot Topics in MS, Cannabinoids, and Gut Microbiota. This webinar series is brought to you by Can Do Multiple Sclerosis, the National Multiple Sclerosis Society, the Multiple Sclerosis Society of Canada, and Meds. My name is Laura Coyne, and I'm the Programs Manager for Can Do MS. I will be your moderator this evening. Can Do MS delivers health and wellness education programs to help families with MS thrive. Please visit the Can Do MS website, cando-ms.org, to learn more about Can Do MS's online and nationwide in-person programs. Can Do MS is excited to partner with the National MS Society to bring you 12 webinars in 2018. The mission of the National MS Society is to help people affected by MS live their best lives as they stop MS in its tracks, restore what has been lost, and end MS forever. You can explore other societies' programs, services, resources, and connection opportunities at nationalmssociety.org. Meds is a national nonprofit that connects people for free and anonymously through their website and helpline to programs that will help them afford their healthcare expenses. Our speakers this evening are Michelle Cameron and Ilana Katz. Dr. Cameron is a neurologist and physical therapist. She is a co-director of the VA MS Center of Excellence West at the Veterans Affairs Portland Healthcare System in Portland, Oregon. And she is also an associate professor in the Department of Neurology at the Oregon Health and Science University. Dr. Katz completed her neurology residency at Columbia University Medical Center, where she was elected chief resident in her final year and was recognized by the Arnold P. Gold Humanism Foundation Circle of Excellence in Teaching. She then pursued a 2-year fellowship in multiple sclerosis at the Corinne Goldsmith Dixon Center for MS at Mount Sinai, which was funded by a Sylvia Lowry Fellowship Training Grant from the National Multiple Sclerosis Society. She joined the faculty at Mount Sinai following completion of her fellowship in 2013. Dr. Katz has a clinical practice at the CGD Center, where she cares for patients with multiple sclerosis and other neuroimmunological conditions. I'm going to turn the meeting over to Dr. Cameron.
Great. Thank you, Laura, and thank you to all of the audience and to Can Do MS, the National Multiple Sclerosis Society, and others who have supported this meeting. Thank you. So I'm going to spend about the next 30 minutes talking about the evidence for and against the use of clinical cannabis, particularly for symptoms of MS. So as we look at the outline for my presentation, which we'll see on the next slide, I'm going to go over what is cannabis, what are cannabinoids, cannabinoid receptors. I'll start with some legal issues, as I'm sure we all know those exist, particularly in this area. I'll go through some of the biology of how this may work, and then look at some specific studies that look at cannabinoids for MS symptoms, and specifically the symptoms of spasticity and pain. And then I'll end with the adverse effects that we know of for cannabis and cannabinoids. I want to make it quite clear right from the get-go that I'm not advocating for or particularly against the use of cannabis, but presenting the data that we have so far, and particularly looking at evidence based on clinical trials, on research in humans. And so what is cannabis? Cannabis is a plant. It's this Cannabis sativa, also referred to the indica species. You can see a picture of it on the left. And as you'll see on the right is a medical marijuana store here in the state of Oregon. So this is how most people are getting cannabis in the United States today. What's the legal status of cannabis? You probably mostly know this. According to federal law, it is Schedule I, which means there is no currently accepted medical use and a high potential for abuse. And so there is no legal cannabis use under federal law. However, when we look at the states, many states have some form of medical marijuana. And we can see that on our next slide, where we see the various states, 30 of them, and the District of Columbia do have legal medical marijuana. Those are all the states marked in dark or light green, and those marked in light green have medical marijuana, but not recreational. Those in the dark green have both medical and recreational. And so we can see 30 states have some form of medical marijuana. It may be quite variable, and 9 have recreational. What do we know about the VA? I work for the VA, and so I do feel obliged to state this. The VA is obviously the federal government, and as long as the FDA classifies marijuana as Schedule 1, VA healthcare providers may not recommend it or assist veterans to obtain it, but we can and do discuss marijuana use with veterans as part of a comprehensive care planning and adjust treatment plans as necessary. And so this is the current state of where the VA stands. You may or may not receive care in the VA, you may or may not work, but I do want to bring up, if you do have a job, that here are just two employers, the OHSU, which is our university, and the VA, that have specific restrictions regarding marijuana use for their employees. And at OHSU, all employees have pre-employment testing and may be tested for cause. So if there's any sort of accident, anything that goes wrong, along with other drug testing, you will be tested for marijuana, and there will be potential consequences. In VA, we have, again, pre-employment testing, and those with direct patient contact can also have random testing as well as for cause. Those without patient contact only have for cause testing. But do consider this for your about your employer. If you're thinking, hey, based on what I'm hearing here, maybe this is something that I want to try, will this interfere with your job or your ability to keep your job? So that's a summary of legal issues. Now let's talk more about biology, which I think is probably what you're most interested in. So cannabinoids are chemicals that are in the plant and that bind to receptors in the body. And cannabinoids we think of in 3 sorts of ways. Phytocannabinoids, the ones found in the plant, and there are over 100 of these. Endocannabinoids, it turns out that our bodies make things that bind to cannabinoid receptors. There are 2 that we found so far, anandamide and 2-AG. And then there are synthetic cannabinoids, things that are manufactured. And we'll also learn a bit more about these. So looking at the cannabinoid receptors, so far 2 have been identified in the human body. These are very creatively named CB1 and CB2. CB1 is located primarily in the central nervous system, so the brain, the spinal cord. This is the part of the body that's affected by MS. And then CB2 receptors are located primarily on cells of the immune system. And so there have been ideas that cannabinoids may affect the immunology of MS, but we really don't have data on the effect of cannabinoids on the disease of MS. We do have data, as we'll look at, on symptoms of MS. So what kind of products are there? So if we look at pharmaceutical products, there is Marinol, dronabinol is a synthetic THC. Nabilone is a synthetic compound that mimics THC. Both of these are available in the US. They are both FDA approved, not for multiple sclerosis, but for chemotherapy-induced nausea and vomiting. The other 3 products that are listed on this page are not FDA approved. Nabiximols, Sativex is an oromucosal spray. It is approved in many other parts of the world. And I think time will tell if this will be approved by FDA in the future. Cannador is something that we'll see discussed that is used in some of the studies, has been used in research in Europe, but is not specifically approved. And then Epidiolex is a cannabis-derived liquid that's mostly made up of CBD. And CBD is one of the natural cannabinoids. This was FDA approved just in June for certain rare types of epilepsy, but is still awaiting DEA ruling as to if, when, how it will actually be made available. So dronabinol, nabilone are available in the United States. The 3 other products are not. So where does this fit in MS symptoms? Most people who are using cannabinoids for MS symptoms are using phytocannabinoids. They're using what's found in the plant in some form, although most of the research that's been done is actually either with nabiximols, so that's the oral mucosal spray, or Cannador, which is pills, so that they very precisely control what people are getting. So let's take a look at what do we mean by symptom management in MS. We'll look at, so as I said, I will look at symptoms and how the cannabinoids affect symptoms. I will not look at disease-modifying effects because the data there are very sparse and none of them are in human trials. What sort of symptoms? We'll see on the next slide, and as I'm sure all of you could tell me, MS produces a wide range of symptoms. If we can get that next slide. There we go. So this is, and this probably is not a complete list of the symptoms that people with MS may have. But 2 of the most common symptoms in MS are pain and spasticity, with about 2/3 of people with MS experiencing pain, over 80% experiencing spasticity. And where we have the most data for cannabinoids is with regards to spasticity. And so that is what I'll spend most of the rest of this presentation, is looking at that, and then a little bit on what we know about cannabinoids for pain. So if we can look at the next slide. The first big statement around cannabinoids for MS symptoms actually came out of 2 different reports in 2014. These were both produced by the American Academy of Neurology. The first one took a look at a full range of complementary and alternative medicine that people with MS might use, and tried to look at, is there good evidence that these work based on research in human controlled trials? And the only thing that was found to have high quality evidence was cannabis. The nabiximols, this is that oral mucosal spray that's got a mix of 1-to-1 THC and CBD, or oral cannabis extract and synthetic THC are probably effective at reducing patient-reported symptoms of spasticity. Also, the nabiximols, oral cannabis extract, and synthetic THC are probably effective at reducing MS-related pain. This was one way of looking at the data. The other way of looking at the data was to say, if we look at medical marijuana in a variety of neurologic disorders, do we find evidence for benefit? Does it help with Alzheimer's? Does it help with Parkinson's? Does it help with MS? And again, the one and only area they found strong evidence was in MS for reducing patient-reported spasticity and reducing central pain. So together, these strongly support that we have evidence that cannabinoids in some forms can be helpful for people with MS. So what I'm going to do now is dig into the studies that really led to these conclusions. And the first of these came out in 2003. This was the largest randomized clinical trial with almost 700 people enrolled, all in the UK. And they had spasticity. They hadn't used cannabinoids before or delta-9 THC. And they were given 3 different options. Either dronabinol, that's synthetic THC, or Cannadol, which is a cannabis extract from a plant with a 2-to-1 THC CBD that they took orally, so a pill, or placebo capsules that were of one type or the other. And when we look at the results on our next slide, what we see is a little disappointing to start with, which is when you have a physician measure a patient's spasticity using this 4-point scale, which is a pretty clumsy scale, you actually find, and the graph on the right shows this, it has 3 lines. First, where people's spasticity starts with, how their spasticity changes after they get the medication, and then what happens. And you'll see everybody's spasticity goes down right away and then starts to climb. But it goes down just as much on placebo as it does on the real thing. So no difference in physician-measured spasticity. But what do we see that shows the difference? And we'll see the next slide. This is what patients reported. And we see the underlined areas of spasticity, pain, and sleep, that those who took either of the cannabis forms, so either the extract or the synthetic THC, about half of them had a reduction or an improvement in their spasticity and in their pain, and actually in their sleep, with only about a third had an improvement on placebo. So what patients experience is different and is significantly different with either cannabis product compared to placebo. And so this supports the statements in those AAN reviews that patient-reported spasticity and pain are improved. We'll go to the next slide. We'll see another of the bigger studies. This was a much later one, about almost 300 people, again with people with troubling and ongoing muscle stiffness, again in the UK, oral cannabis extract or placebo. They start to take a capsule twice a day and then could keep taking more up to whatever was right for them, basically, with a given maximum. And let's go to the next slide. We'll see the outcomes they looked at. So rather than physician-rated spasticity, they made their primary outcome a numeric rating scale, which is what does the patient say? And I will show that to you in a moment. But almost twice as many people taking cannabis extract as those taking placebo reported relief from muscle stiffness. About 30% with the cannabis extract, about 15% with placebo, so twice as many. There also were improvements in spasms, pain, and sleep. I'll just go quickly to this next slide just to show you what a numeric rating scale is. Basically says, please indicate your level of spasticity over the last 24 hours on a 0 to 10 scale. And let's now look at, here we have a series of 4 studies done over a number of years. We have over 1,200 patients in these studies overall. They're all what's called double-blind, randomized, placebo-controlled. That means people get either the real thing or placebo. So they both get a spray. The spray is actually peppermint flavored, so they both get the peppermint flavored spray in the mouth. But some get it mixed with the cannabis, some don't. And again, they're told to just up the number of sprays they use to get the right balance for them. And what are the outcomes, the results of this? We'll see that in our next slide. They again use that numeric rating scale that I mentioned. We had better control of spasticity with nabiximols than with placebo. And people took about 20 to 40 milligrams of THC a day. They didn't just keep going up and up and up. But we do start to see some adverse effects. Dizziness, problems with attention, fatigue, disorientation, feeling drunk, vertigo. I think things people might expect. And we'll see now in the next slide, here's a graph to show the comparison. So the dotted line is people on placebo, and they show some improvement. The black line is people taking the nabiximols, that oral mucosal spray of THC and CBD, and they do better. The spasticity is more reduced. So in summary, as I'll show on the next slide, the data do support that cannabinoids can reduce the severity of self-reported spasticity. But realize all the randomized controlled trial data is from specific oral or oral mucosal spray preparations, not smoked cannabis, and neither of these are specifically available in the US today. Also realize about 50% of people seem to keep using. About 50%, even in the trial, stopped because either they said, this doesn't work for me, I don't want to keep doing it, or they had adverse effects sufficient to say, I don't want to do this. How much people use seems to vary. Certainly, all the studies said they start people with a low dose and actually allow the patients themselves to go, where's the sweet spot for me? And most people seem to find that at around 20 to 40 milligrams of THC a day that they take over the day. So that's what we know in our brief summary of cannabinoids for spasticity. And now as we look at pain, as I said earlier, pain affects many people with MS, all sorts of pain, mostly what we call central neuropathic pain. And as we go into the next slide, we'll see what do we have from the research on this. We have the same two trials I mentioned earlier, the CAMS trial and the MUSEC trial. So their primary goal was to look at spasticity, but they also looked at pain, and they showed reductions in pain. Some studies have been done specifically to look at pain. This one, quite a bit smaller, 66 people with MS and pain. They were either given nabiximols, the spray, or placebo for 4 weeks. And those who took the nabiximols had a 41% reduction in their pain compared to a 22% in those taking placebo. So again, about twice as effective as placebo. This was statistically significant. And our next slide, we'll see a little bit more. This is a tiny study in 15 people with MS and neuropathic pain. And they actually said, if you're taking gabapentin at a substantial dose, 1,800 milligrams a day, and we add nabilone, that's that synthetic oral THC, will it help? And they did find that those who had this added, and again, compared, was titrated up, had less pain and less pain impact, more if they had this than if they were taking placebo. And in general, this was well tolerated. So I think you can see for this, again, some moderate evidence that cannabinoids can be helpful for pain in MS, again, using either synthetic or highly controlled products. But what's the downside? And everything comes with downsides. In therapeutic trials, so the trials that we've talked about already, where they're looking for benefit but also monitoring adverse effects, mostly things I think people would expect: dizziness, confusion, drowsiness, fatigue, nausea, some dry mouth, or increase in appetite. There have been a couple of studies that have looked at specifically adverse effects, and these are mostly looking at people who are current users rather than actually giving them cannabis, but comparing regular cannabis users to non-users. And as you can see on the slide, these are studies in 20, 25 people with use or not use, or 20 users, 19 non-users. Those who were using cannabis on a regular basis did have slower information processing speed, worse working memory, worse executive function, and were twice as likely to be cognitively impaired. And as we know, MS can affect cognition. So likely although you may see benefit in some areas, you will see adverse effects around cognition that may make it not worth it. And then one more study, there is one directed study that specifically was focused on adverse effects of cannabinoids, giving it to people. This was for people with pain, not people with MS. They had about 250 people. They gave them cannabis or a non-cannabis herbal, and there were no differences in serious adverse events, but non-serious events were more common in those who had the real cannabis, with headache, runny nose, nausea, somnolence, dizziness, upper respiratory tract infections, vomiting, and cough. So other adverse effects that I think are important to recognize, there is an increased risk of developing psychosis and or schizophrenia, particularly with high doses. There's tolerance, which means as you use it, it will do less with the same dose and you may need more and more. And about 9% develop dependence, where they have withdrawal if they stop. There's also possible increased risk for heart attacks, high blood pressure, heart failure, and stroke. And there is this rare phenomenon, which is called cannabinoid hyperemesis syndrome, where people who use large quantities of cannabis over a long period of time start to actually get vomiting. So cyclic episodes where they vomit, and the only thing that helps them is a hot bath or hot shower, and the only thing that stops it completely is to stop using. And one last slide on adverse effects that isn't related to any of the cannabinoids I've mentioned, but there are things called synthetic cannabinoids like spice and K2 that may be contaminated and have been associated with very bad side effects, stroke, either ischemic or hemorrhagic, and seizures, and definitely to be avoided. These are quite dangerous. So in conclusion, and then I'm happy to take questions, I think you all know, and as people mentioned, about 25% of you have used cannabis or a cannabinoid in the last year. Cannabis is increasingly available. 63% of you live in states where it is available, and there is a growing interest in its use. There are multiple forms and formulations, and in multiple sclerosis, the best evidence for benefit is for reducing patient-reported spasticity. About half of the people who use it find it's helpful. However, this is with specific combinations of THC CBD products that at least to date are not specifically available in the United States. Dosing does vary, and if you're going to try this, start low, increase slowly, and be aware there are risks, likely similar to those in other populations: dizziness, imbalance, feeling drunk, these increased risks of psychosis, the cannabinoid hyperemesis syndrome with heavy use, and specifically in MS, there is this risk of worsening cognition. So I hope you find this helpful in guiding you in making your own decisions, and I'm happy to take any questions.
Great. Thank you very much, Dr. Cameron, for all that research and information that you presented. I did get a number of questions. One question really is kind of looking at the different strains of marijuana. And, because if you go into a store, there is various kinds, if you will. So is there any best strain for marijuana, or can you talk a little bit about the different strains?
I don't think we know at this time if one strain is better than another. I think what we know is that we have evidence that either a 1-to-1 or 2-to-1 THC CBD ratio is at least what's been tested in these pharmaceutical products to be effective. Not that one is better than the other, or that some other combination might not work, but that if you're trying to match what they've used in the studies, those are the things they used that they found to be effective. A 1-to-1, so an equal amount of THC and CBD, or twice as much THC as CBD in it. And generally, the strains are labeled with that information.
Great. We also had a number of questions versus cannabis that is smoked versus cannabis that is edible. Can you comment on that and in those two different forms of marijuana?
Absolutely. So we have no trials on smoked cannabis. All the trials here were either using that oral mucosal spray or swallowed capsules. And we don't really have anything on the smoked versus edibles available in the dispensaries. What we do know that's different about them is how quickly and what they work and how long they work for. So smoked cannabis will give you an effect within 2 to 3 minutes up to 15 minutes where you'll get that peak effect that will last probably a couple of hours. Ingested, so cannabis that you eat, will take longer for you to feel it and longer for it to have an effect. Could take even up to a couple of hours, but then will last more like 5, 6 hours. And so it lasts longer. You need to be particularly careful with cannabis you eat that if you don't feel anything in an hour or so, don't just take more and more, because then it'll start to add up down the road.
Great. We did have some people ask about cannabis and insurance. Is there any instance where cannabis is covered by insurance?
The only way that I am aware of is right early on I mentioned dronabinol and nabilone. These are cannabinoid product pills, one THC, one synthetic THC, that are FDA approved for chemotherapy-related nausea and vomiting, and one for appetite stimulation in HIV. And in those circumstances, I believe there are times when insurance will cover it. And even that I could not be certain. I mean, every insurance is different. I have not seen it cannabis in any form for MS covered to date.
Great. I know you touched about the legal issues. We did have some questions about state law versus federal law. Which one precludes the other?
I'm not a lawyer. I really couldn't speak to that. I'm sorry.
No worries. Thank you for that answer. I also got a question about cannabis and anxiety. Is cannabis a good solution to anxiety, which is often associated with MS?
Really varies from one person to another. THC may actually worsen anxiety in some people or improve it in others. CBD generally does not worsen anxiety, but you really will find quite variable responses to THC.
Great. I know you talked a little bit about sleep and marijuana. Can you touch on what products might be good for people who are experiencing sleep disorders or sleep issues?
So again, an interesting thing. Although, the one study that was using, and I will just double check it, the CAM study. So the CAM study was, I'm just taking a look at my slide so I'm sure. Right, so both forms, so either dronabinol or Canadol, so either all THC or a 2-to-1 THC CBD combination, did seem to help with sleep in people with MS. So one could, I presume, derive from that this could be helpful for sleep. There aren't really any studies in MS specifically looking at sleep, and the studies looking at sleep in other populations are actually rather poor. And they're just not well done, so we can't conclude much from them.
I got some questions about folks that have MS and seizures. Is cannabis ever been noted to help with seizures?
A very interesting question. So CBD, which is what's in Epidiolex, was one thing that's made it through FDA and waiting for DEA for special, for rare forms of seizures, has been shown to reduce seizures. On the other hand, THC has actually been shown to possibly worsen seizures. So depends what's in the cannabis, which direction that's going to go.
Great. Well, I think that's all the time we have for questions. So I want to thank you very much for all the information. And again, for really looking at the research and all the information that is currently available on this topic.
You're welcome. Thank you.
And the second part of our hot topics in MS today is going to look at the role of microbiota in multiple sclerosis. And with that, I'm going to turn the meeting over to Dr. Katz Sand.
Thank you so much for having me. Thank you to Can Do MS and to the MS Society, and thanks to all of you for tuning in. So just as an overview, we'll start by talking about MS and the role of the environment. We'll talk about some background in terms of gut microbiota and the role of gut microbiota in health and disease. We will discuss microbiota mechanisms of influence and ties to immunity. So thinking about how microbiota can affect not just the local immune system, but the immune system in the entire body. We'll talk about what happens when the microbial balance gets disturbed, a term referred to as dysbiosis, and various disease states. Then we'll look at the evidence for a role of gut microbiota in MS, specifically therapeutic potential related to microbiota and MS. And then we'll finish by thinking about some open questions for research and future directions for this work. So MS, as we all know, is an inflammatory disease of the central nervous system. Primarily, we think of MS as an autoimmune disease, and that leads to inflammatory lesions, as everyone knows, in the optic nerves, the brain, the spinal cord, clinical relapses, and in some patients, progressive disease. We know that MS is the leading cause of neurological disability among young people, and despite the fact that we've done really well in the field over the last few years with new treatments, we still have a lot of room for improvement. And therefore, we should continue to be aggressive in searching for new avenues of research that might be helpful. So this is a schematic of the immune system in MS, and it's very complicated. And I show this to you not to frighten anyone, because it is quite complex, but really to point out that there are many different immune system components that we now think are important in MS. So what I'd like to really highlight here is that the immune system has parts that are pro-inflammatory, promoting inflammation, and parts that are anti-inflammatory. And you can see that reflected along the bottom by things that are in red that are thought to be inflammatory versus in green that are thought to be promoting tolerance or regulation of the immune system. So we think that this balance is disturbed in MS. The good thing here is that all of these different components of the immune system really represent opportunities in terms of treatment. So we can target this balance. And we already take advantage of these relationships with our disease-modifying therapies. And this is the model that we're going to be thinking about when we get to talking about interactions with the microbiota as well. So thinking about the etiology of MS, something that we still don't completely understand. So we know that MS is caused by some combination between genetic factors and environmental factors. We think that the environmental contribution is really quite substantial. And we know about some risk factors. We know about smoking being a risk factor for MS, having a low vitamin D level, exposure to certain viruses, obesity, particularly in adolescents. But there's really still quite a lot that we don't yet understand. So where do we look for environmental factors that might be important? Well, that brings us to the gut, actually. So we've already established that MS is primarily an autoimmune disease that affects the balance of inflammation versus tolerance. And it turns out that about 70% of the body's immune system is actually housed inside the gut. The gut's resident immune system is really important regarding influences on immunity and in the rest of the body. So then we really have to think, okay, what is inside the gut that could be affecting the immune system balance there? And the answer is the gut microbiota. So let's talk a little bit about the gut microbiota. First of all, what is all this about? So humans are really heavily colonized with commensal flora. It's kind of gross to think about, but we are all completely covered in microbes from head to toe. So not something nice to think about on a daily basis, but really that's really the case. So microbiota are defined as the collection of microbes that colonize the human mucous membranes and the skin. And the extent of what's normal has really only been very recently characterized in studies that have come up really in the last 10 years or so. We already knew that there was a symbiotic relationship between the human host and many microbes. So, for example, in processing of nutrients, we have co-evolved with these microbes over many, many years. And there are a lot of things in our food, for example, that we would not be able to digest or process or gain vitamins from without these microbes. We know that the microbes we have are also important for resisting infections, which might be counterintuitive, but actually many of our microbes, especially in our gut, and this turns out to be very important with relation to autoimmune diseases, these microbes are important for maintaining these mucosal barriers that we have that keep bad bacteria out. And the thing we're going to focus on today is that the flora that we are colonized with are really important for immune system patterning. There's a lot of communication between the bacteria and our immune systems, and that's going to be the focus of the rest of our talk. So the role of microbiota in many disease states, particularly in autoimmunity, is now being recognized and investigated. Each person has a unique set of gut bacteria, and in fact, your precise microbial composition is as unique as a fingerprint. So the question is, what influences each person's gut microbial composition? What makes each of us unique? So there are certain factors that we know about already. Mode of birth, so whether you're born vaginally or by C-section is important. When you're born vaginally, the baby is colonized by flora that come from the birth canal, as opposed to when a baby is born by C-section, the colonization initially is primarily skin flora. So that's significantly different, and there are differences that actually persist for many years beyond that. Whether a person was breastfed as an infant or formula fed, again, produces a stamp on the microbiota that can be seen many years into the future. Age is a factor, so the microbiota is actually relatively stable throughout life if the other factors are held constant until about age 60 or 65, when we start to see some changes as people get a little bit older. Antibiotic exposures are really important. Again, as we think about issues that we have in terms of antibiotics in the food supply and antibiotics that are being overused to treat viral infections and things like that, we really need to be judicious about antibiotics for many reasons. But it turns out to be very relevant in terms of our microbiota, right? Each time we take a course of antibiotics, there's a stamp that's left on our microbial composition. Genetics, we think, is probably important. We don't know too much yet about genetic factors and influences on microbiota. Diet is really the most important long-term driver of microbial composition, and we'll talk about that towards the end of the talk. And then disease states and medications, we're really just learning about now. So now let's discuss the science behind how it's possible for these bacteria to impact the immune system. So we have the microbiota here, and you can see right here where it says microbiome and these little bacteria there. So as we said, each person's bacterial profile is really unique. And we can see here that the microbiota can influence the immune system in two different ways, represented by these two different arrows coming out here. So one is through direct influence of the bacteria. So there are surface markers that are present on different bacteria, and they can interact directly with the cells that line the intestine and also the surrounding immune cells. The other mechanism is through production of metabolites, so signaling molecules that can have local effects on those cells in the intestine, but also can actually diffuse throughout the body and even to the brain. Along the bottom of the figure here, we can see that through these mechanisms, the microbiota can influence, for example, on the left, you see the integrity of the intestinal wall. So we mentioned before about mucosal barriers. So the integrity of the intestinal wall is really important. When the intestinal wall gets breached, all kinds of bacteria that don't belong inside can get in and can improperly rev up the immune system. We think that's important. We know it's an important model for inflammatory bowel disease, for example, but we can see how that might be important in other autoimmune diseases as well. So the microbiota can also influence the identity of immune cells. So next to the second from the left, there's a schematic there that shows in gray a naive T cell. So T cell is one of the kinds of white blood cells from that initial complicated slide that we think to be involved in MS. And when a T cell is born, it can either end up becoming a pro-inflammatory cell and cause inflammation, or it could become kind of a regulatory anti-inflammatory cell. And it turns out that the microbiota are important in determining the ultimate identity of those immune cells. So we can kind of start to get a sense of how microbiota have an important influence on the immune system. So this is another schematic illustrating the same principle. So here you can see that, for example, with the intake of dietary fiber, the microbiota, in response to fiber coming in, those commensal bacteria, the microbiota, will produce short-chain fatty acids, one of those metabolite signaling molecules that I had mentioned. Short-chain fatty acids have important effects on, as we just said, maintaining barrier integrity, on working on the immune system balance. So as we just said, shaping the identity of what the white blood cells grow up to be, whether they grow up to be things that are pro-inflammatory or anti-inflammatory. And then along the bottom, you can see that those metabolites also diffuse into the bloodstream and have distant effects throughout the body, including in the brain. So now let's get into what we think happens when the microbial composition shifts in a way that is unfavorable, and that is sometimes referred to as dysbiosis. So as we mentioned, there are various factors that can affect the microbial profile, such as the route of birth, diet, infections, antibiotics. So that can affect microbial composition over time. So this can reach a point, which we can see here in part B of the figure, where the balance gets tipped toward inflammation, and that can have really important consequences. Alterations in the microbiota composition have now been linked to multiple disease states, ranging from psychiatric illnesses to diabetes to cancer, and of course to autoimmune diseases such as MS. So we first began studying the role of gut microbiota in MS patients because of some interesting studies that were done in animal models of MS, which I will now show you briefly. We'll look at a mouse model called EAE, which you only need to know as EAE, stands for experimental allergic encephalomyelitis, which is a huge mouthful, so we'll stick with EAE. And for purposes of this talk, we're just going to think of EAE as mouse MS. Okay. So this was one of the initial studies that really spurred this whole line of research. If we can actually go back one slide. Yep, okay. So what we learned in this first observation was, if you treat mice with oral antibiotics that wipe out the gut flora, and then you try to give them EAE, that mouse MS, the course of the disease is much milder than in mice who do not get the oral antibiotics. And you can see this represented on the graph here. So the EAE clinical score is on the y-axis, along the y-axis there, and higher scores indicate worse disease. So you can see here that the mice that were treated with the oral antibiotics, represented by the line along the bottom with the filled in boxes, those mice had much lower scores. What was also really interesting about this study is that the researchers also noted that there was less inflammation, not only in the gut, but throughout the body. So this next experiment showed us that the presence of gut bacteria seemed to be required for the mice to develop EAE at all. So mice that were raised in a totally germ-free environment actually do not seem capable of getting EAE. So this is a model that researchers used where there's a genetic modification such that the mice spontaneously develop EAE, this mouse MS. But here what they noticed was that when the mice were raised in this germ-free environment, they really did not get EAE. However, as soon as you colonized the mice with regular old, normal commensal bacteria that they saw in other mice, As soon as they colonized them, then the mice became sick. And this shows us that the gut bacteria have powerful effects on immune system patterning. So the last experiment I'll show you in animal models is one that has been done by our collaborator, Dr. Mazmanian at Caltech. Here we worked with 3 groups of mice. So one was a set of germ-free mice, raised in a totally germ-free environment, which as we saw in the last slide, they don't really get EAE. And so those are the ones that had the lowest scores in that black line there along the bottom. For the other 2 groups of mice, I think this is pretty interesting. One was transplanted with human feces from an MS patient, and one from a donor without MS. And you can see the difference between the red line, which is the one that was transplanted with the MS patient feces, and the blue line, which is the donor feces, such that the mice transplanted with feces from the MS patient had much more severe EAE, which we think is pretty interesting toward the argument that the relationship between microbiota and MS may be one that is causative and not just an association. So the next question is naturally, what is the evidence in humans? So this slide is from a recent review summarizing work that's been done on the microbiota in MS patients thus far. And I included here, again, has a lot of things on it, but really the important thing here was just to show you that the studies that have been done so far have mostly been very small, and there's really not been a lot of agreement between them. Part of the reason for that, I think, and I'll show you this in a little bit, is that a lot of the studies did not really fully consider the effects of treatment, and that makes it hard for us to know whether the observed differences between people with MS and people without MS are really due to the disease itself or due to treatment effects. We'll spend a few minutes now going over the work done by our group, which is between Mount Sinai and UCSF, since this is the largest cohort of untreated MS patients that have been looked at so far. Okay, so what we did learn from our study was that there were some differences between the microbiota in MS patients and those without MS. So this figure here, this type of figure is called a volcano plot. And each dot represents a particular genus of bacteria. The plot shows a ratio between MS and controls, and therefore those that are close to 0 were similar between the 2 groups. The further away we moved from 0, the more different the abundance of that bacteria was between the 2 groups. So those that are on the right in green were more abundant in MS, and those that were on the left in purple were less abundant in MS. So we next wanted to start thinking about what could be the potential consequences of these differences. So we're going to zoom in on one genus from each side. So here we'll take a look at Akkermansia. So Akkermansia is a genus from the right side of the plot, meaning that it was more abundant in MS, as you can see in the plot here on the left. And then thinking about the functional consequences of this, the plots on the right show that the presence of this bacteria seems to be associated with an increase in immune cells with pro-inflammatory markers. And therefore, this could be important in MS. So this is an association between a bacteria we see higher in MS patients compared to people without MS and inflammatory cells. So we think that could be potentially important. So now looking in the opposite direction, Bacteroides was less abundant in MS, as you can see by the figure on the left here. And interestingly, Bacteroides seems to be associated with an increase in markers on cells that indicate they're anti-inflammatory. So the fact that this bacteria, which we think is probably an anti-inflammatory type of bacteria, seems to be less abundant in MS, we think that might also be important. Here I just wanted to quickly show you some of the work that we've done looking at the impact of disease-modifying therapies on the microbiota. And you can see from these 2 plots here that dimethyl fumarate and glucuramine acetate, 2 MS disease-modifying therapies, were both associated with changes in gut microbiota when we compared patients on those therapies to patients who were not on any therapy at all. And we think this might be important with regard to how the medications work, might be important for helping us to determine how well patients respond to medications, but really we need to do a lot more work on this topic first. So what have we learned from these early studies? Well, I've shown you that MS patients show differences in gut microbiota composition compared to controls at the L6 or the genus level. Reproducibility has definitely been an issue in these early studies. As I said, I think mostly relating to small sample sizes and to lack of consideration for treatments. We know that MS disease-modifying therapies seem to have effects on gut microbiota, and we need some further studies to understand how this might be relevant clinically. So a big part of the issue is that interpretation of the data seems to be complicated by noise in the data sets. So one of the things that we've noticed, for example, in our collaborative work, which has been between our center at Mount Sinai and UCSF, is that there are differences, for example, in the control groups between the two sites. And that tells us that there are some other factors besides MS that might explain some of the variation. And that tells us that we really need to start designing some bigger and better studies to study this topic. So we're hoping that the International MS Microbiome Study is going to help us answer a lot of our questions regarding the role of gut microbiota in MS. So IMS-MS is truly an international collaboration. It's run by Dr. Barancini at UCSF and funded by a philanthropic gift to the institution. And you can see all the participating centers around the world. So IMS-MS aims to collect samples as well as clinical data from over 2,000 MS patients around the world, as well as not only those patients, but each patient is actually entered along with an genetically unrelated household control to help us filter out some of what we call the noise in the data set. So each participant completes a basic clinical questionnaire, some standardized clinical assessments, and then provides the study with stool samples and a blood sample. And we think that the power in this study is going to be much larger than previous to detect some potentially important differences because we have a much larger sample size here, obviously 2,000 patients as opposed to, in our study, we're talking about 70 patients. We have standardized sample and data collection, so all of our methodology has been worked out over the past few years and everything is standardized. And as I mentioned, we are enrolling patients along with household controls. And this effort also funds ongoing animal model work, such as some of the work that I've showed you, looking at germ-free mice, and those facilities are difficult to set up and maintain. So, of course, our biggest question is how can we translate what we are learning to benefit people living with MS? So getting into some potential future applications. So the first question is there a particular microbiome signature that can help us with diagnosis? So can help us make an MS diagnosis when, in cases where we're not sure. With prognosis, so is there a microbiota signature that will predict who is at risk for more severe MS and who should be put on a more aggressive treatment up front? Predict who's at risk for developing progressive disease. We have a project going on right now to look to see whether there are differences between patients, for example, with primary progressive MS compared to relapsing remitting MS, and see if there are important differences in the microbiota between those populations. Is there a particular signature that will help us predict response to disease-modifying medications? That would be really wonderful, right? It's something that we always consider as clinicians when we're prescribing a treatment, that we really don't have great biomarkers to tell us who's going to respond well to a treatment and who's not. Particularly with the oral medications, I think the microbiota might turn out to be very important in predicting therapy response. So in terms of potential therapeutic applications, we'll break these out a little further in a moment, but the overall ideas are we could directly manipulate the microbiota through the use of probiotics, fecal transplant, or antibiotics. We could try to indirectly manipulate the microbiota through prebiotics or diet. We could try to bypass the microbiota entirely through administration of beneficial metabolites like short-chain fatty acids. So in terms of direct manipulation of the microbiota, we could try using a probiotic, for example. There's been a pilot trial of a study of an agent called BSL-3 by the Harvard group, which is potentially interesting. It's very early stages, but they were able to demonstrate that use of this particular probiotic could actually change the microbial composition and that had effects on the immune system. So we'll have a bit more work to do to see whether that has any efficacy in MS, but pretty interesting. We're thinking about fecal transplant. I think before we can really think about efficacy, we have to consider, is this feasible, sustainable? In terms of antibiotics, a big issue with antibiotics, as I mentioned, is they have a lot of side effects and they can wipe out. It's hard to make them very targeted. So I think that's a major issue, but perhaps we could come up with some antibiotics that were very targeted. So then we come to the idea of indirect manipulation of the microbiota. So for example, with a prebiotic, an example of a prebiotic would be the administration of fiber, as we had discussed earlier, to induce the production of short-chain fatty acids. And then we come to my personal favorite topic, which is diet. So as I mentioned, diet is the most important long-term driver of microbial composition. And so I think it's extremely important to think about diet from a angle of research in MS, and we're doing a lot of work on that now. So to conclude, we have trillions of microorganisms in the human gut. Gut microbiota play important roles in human health, including in immunologic patterning. There are established links between gut microbiota and several disease states. We have some preliminary evidence for a role for gut microbiota in the development and course of MS. And there are several potential therapeutic approaches related to microbiota, including the possibility of dietary intervention. And research in this area is ongoing. I'd like to, of course, acknowledge all of my collaborators in terms of the research that I presented today, and particularly the MS Society for funding our work and our patients for their participation. And with that, I'd like to thank you all for your attention. Happy to take any questions.
Great, thank you, Dr. Katz. Can you talk about some resources that the layman living with MS can access to research this topic further?
Oh, that's a great question. Well, we have some things on the IMSMS website. I think that's a great place to start. I think there's not a particular other than the IMSMS website, which does have some good information on it. There's not too much out there that I would say, like a particular site, for example, that I think has done a good job of putting this stuff together. But that's a really good point. We could definitely think about putting together some content that could be posted somewhere to one of our websites going forward.
Great. I know you talked a little bit about diet as we were getting to the end of the presentation. Is there, we had a lot of questions about, what best foods might help someone with an autoimmune disease. Is it, a combination of vegetables, fruits, and grains? Is it, meats? What kind of food recommendation would you make?
I think it's an excellent question. It's one that I try to answer every day, every time I'm seeing patients. It's something that we're talking about, and I think it's going to turn out to be really important. But the answer right now has to be that we just don't know. The research really has to be done. So I cannot stress enough how important it is that we really work on research on diet in MS. So what I always tell my patients is, I would never recommend that you go on a medication because my friend took it and thought it was good, or, someone wrote a book about it. We try to make our recommendations based on evidence and based on science, and that requires really good scientific studies, and particularly it requires clinical trials. And we're only at the beginning of that research now. So I personally am of the mind that I think what's going to turn out to be best for the most people, keeping in mind that this might not be best for everyone. What I'm doing a study on right now is a modified Mediterranean diet, and I developed the diet for our study based on what I thought was best available information in the literature, basic science studies and epidemiologic studies, and tried to kind of put together a diet that I thought made the most sense. But we have so much more work to do in terms of testing. So what I recommend to my patients for now, because of course people want to do something now and they don't want to wait for the research, which is completely understandable. What I recommend is that people follow a generally healthy lifestyle. I can't be certain that following these recommendations is going to be helpful for MS until we really get the research done. But I think it's reasonable to follow recommendations that we know to be good for general health, heart health. And so I usually tell patients, as much as you can do in terms of fresh fruits and vegetables. I would favor fish over meat in general. Principles like staying away from processed foods and sticking with fresh foods as much as possible. If you're going to have grains, you should try to make them whole grains that have good nutritional content, high fiber. So those kinds of recommendations, which are really recommendations I think that anyone can benefit from.
Do you have any recommendations on a gluten-free diet or dairy-free diet?
So I don't generally recommend gluten-free diets. I think that they're important for people who have an allergy to gluten or a particular intolerance to gluten. And if gluten makes you feel unwell, you should avoid it. But I don't think that there's no evidence actually to support a gluten-free diet, specifically a gluten-free diet in MS. Even really, there's no basic science research that would support a gluten-free diet in MS. So I don't really recommend it for my patients, again, unless they have a specific gluten intolerance. I tend to recommend that people, as I said, stick with whole grains. You also have to be really careful about gluten-free products. So if you want to avoid gluten, what I recommend is, again, sticking with just fresh foods. I really recommend against specific gluten-free products like gluten-free breads or gluten-free chips or things like that, because those tend to be full of processed chemicals, and I think those are probably worse for you than gluten, if gluten is even bad for MS, which we haven't shown that it is. In terms of dairy, we have a little bit of basic science evidence that suggests that dairy might be inflammatory, but again, we need to do a lot more work. It's possible that the problem with dairy is the fat in dairy, so perhaps low-fat dairy might be okay. It's possible that certain types of dairy are not good, whereas certain types are okay. For example, maybe yogurt's going to turn out to be okay because of probiotic effects. Or maybe it's all going to be bad, or maybe it's all going to be fine. We really just don't know. So my current recommendation for dairy is, again, same as it would be in terms of general health, which is dairy is something that probably should be minimized. When you think about it, it's a little bit strange that we take milk from another species, a lactating species, right? But ice cream is very delicious. So I don't tell people that they should overhaul their life and eliminate, ice cream and pizza if they enjoy having those things now and then. I think that's okay for now. We haven't proven that it's bad.
Can you also touch on how caffeine affects MS, and if it does or not, or does not?
We really don't have any specific good research on caffeine in MS. There's a literature about caffeine and headaches, for example, which are increased in MS patients, and caffeine can be problematic for certain patients. Caffeine, I think, just anecdotally from clinical practice, I think probably helps some patients with their fatigue, although it's something you don't want to abuse or overuse. It can lead to a lot of problems. But there's really not a specific literature about caffeine in MS, especially with relation to, diet, microbiota type stuff.
Is it possible to reverse damage to the gut?
That's a great question. I think so. We know that, for example, in inflammatory bowel disease, when people make certain dietary changes or go on certain treatments, that on pathologic studies, when they get rebiopsied, that the damage is decreased. And so, the mucosal barrier, for example, can be improved and restored. I'm not sure if there's been a lot of damage there, if it's possible to reverse it entirely, but I do think it's possible to improve, yes.
Great. So we have time for one more question. And as we conclude, we did get a lot of questions about probiotics. Can you just kind of touch on that a little bit more?
Sure. So probiotics is something I hear about every day. Again, I have a lot of patients who come in and tell me they're already taking the probiotic for their MS. And what I tell them is similar to my advice about diet, although this is with an additional caveat because it's a supplement, which is that the research is just not there to support it. So as I mentioned, there's been only one pilot trial on a particular probiotic in MS, and that was too small to tell us whether it's helpful or not helpful. So that study was helpful, at least in telling us that we are able to change microbial composition with probiotics, we think, at least a little bit. But since we haven't quite figured out which are the bacteria that we're certain are, implicated in making MS worse or making MS better, it's really hard to know which type of probiotic might be helpful, right? If you look up probiotics, there's tons of different ones with all different kinds of bacteria. So we're not yet at the point where we even know which are the bacteria we think are going to be good for MS and which are the bacteria that we're certain are going to be bad for MS, right? So that's kind of the first step. And then we have multiple other steps in between before we can really determine whether a probiotic is going to be of benefit in MS. That being said, if you have, for example, GI disturbances are common in our patients' constipation, there are particular probiotics that can be helpful for those types of problems, depending on what type of GI issues you have. But I don't recommend them, just for MS, because again, the evidence is not there. In addition to the evidence not being there and thinking about things like diet, you have the additional layer of the fact that these are supplements. They are not regulated by the FDA as drugs, and you really have no idea what's in them when you buy them off the shelf.
Well, Dr. Katz, I want to thank you for providing an enormous amount of information on this important topic. And I also want to again thank Dr. Cameron for her discussion on cannabis. So thank you both. We very much appreciate you being part of our webinar series. And with that, I would like to conclude by informing you of some additional resources that you might find informative and helpful. On the CanDo MS website, CanDo-MS.org, you will find archived webinars, e-news, library articles, and CanDo On Demand. You can also submit a question to the Ask the CanDo team, which will be answered by our team of MS experts. I'd also like to highlight some of the resources available from the National MS Society. They have a variety of brochures and video segments that can be accessed on their website, nationalmssociety.org. And you know what? This is CanDo Month. CanDo Multiple Sclerosis would like to invite you to celebrate CanDo Month by sharing a photo or video of how you kick MS. This could be running, painting, camping, traveling, cooking, singing, loving anything you do to live passionately and thrive with MS. I invite you and ask you to share your photo or video on social media by using the hashtag CanDoMonth. You can also submit them online at cando-ms.org/CanDoMonth. Show us how you kick MS. Make your CanDo Month statement today. I'd also like to invite you to find some additional resources at www.mspath2care.com to learn more about the importance of shared decision-making in MS. The next presentation in our webinar and telelearning series will be on Tuesday, October 9th at the same time, 8 p.m. Eastern Time. The topic next month is nutrition. And as always, you can register for the webinar series free of charge on the CanDo MS website. If you'd like to text to donate to help support our webinars, you can do so by dialing 970-626-6232. And finally, for those participating live tonight, you will see a survey appear on your computer screen. I would encourage you to take a moment to complete the survey and share your input. Your feedback does help us to continue to improve our webinar series. So thank you for joining us and have a great evening. And once again, thank you to Dr. Katz and thank you to Dr. Michelle Cameron.